Okay. Hi guys, this is a video of the second half of Chapter 7, Lesson 3. We got halfway through in our meeting, online meeting, but then we glitched out. So I'm going to continue with the graphing part. So here, first you're looking at a picture from the textbook. Logarithmic functions and expressions. Consider the exponential function. Here we go. Consider the exponential function f of x equals 2x and its inverse. Okay, f of x equals 2x is this graph right here. Okay, that's an exponential growth graph, if you guys remember from before we started having to stay home. Exponential growth. I told you earlier that logarithmic functions are inverses of exponential functions. And remember, when graphing inverses, the graph of an inverse is always symmetrical about this line. Okay, so the graph that's symmetrical to that blue line is this red line, and that represents a logarithmic function. If you just switch the x and the y, that's the graph of the logarithmic function x equals 2 to the y power. Okay, so we're going to practice a little bit of graphing. Okay. The graph of f of x equals log base b of x, right here, is the parent graph of all logarithmic functions. All right. You can look in your textbook for characteristics of the graphs. Let's see if I have that down right here. If you'll notice that you can notice a couple things about the graphs. For logarithmic functions, the base, okay, first off, is always going to be a positive number, and it can't be 1, all right? And x is always going to be a positive number. And with that in mind, that helps us with graphing. If we look at this, remember this represents the b. Remember in logarithmic form, log base b of x, okay? So let's look at the graph of f of x equals log base 3 of x. Now, you guys don't have this part on your notes, but go ahead and write it in. I made a little data table and I put 3 values in for x, 1/3, 1, and 3. Now, why would I use those numbers? It's because they're easy to do. They're easy numbers. You do not need a calculator to use these numbers. For example, if you put 1/3 right there, okay, you have log base 3 of 1/3 equals y. All right, now, if you write it in the other form like we practiced up top, this would be 3 to the y power equals 1/3. Well, what would y need to be to make this true? All right, well, hopefully you guys remember your exponents pretty well. 3 to the negative 1 equals 1/3. That one's pretty easy because you just flip it over. So that means for this value here, we get negative 1. All right. Now, let's do it again. Let's use 1 right here. All right. If we put 1 right there, what's y going to be? If you write it in the other form, you get 3 to the y power equals 1. Well, what would y have to be? Well, if you recall your exponent properties, anything to the 0 power equals 1. So this is 0. So it's another easy one. Next one. Let's put 3 right here. All right. So if we write this in exponential form, we have 3 to the y power equals 3. Well, that's a pretty easy one, 3 to the first power. So there's our 3 values. So let's graph this. When x is 1/3, y is negative 1. about right there. When x is 1, y is 0. Right there. And when x is 3, y is 1. And here we have, that's enough to get our graph. Okay, there's the graph. Now, what you're going to find out is it would be impossible to get an x value of negative. X cannot be negative, okay? Why is that? Because this value right here can never be negative. Because if you take, since b has to be a positive number, remember this is your b, since b has to be a positive number, no matter what exponent you use, you will never get a negative number here, okay? You can get a smaller and smaller number, a fraction, but it will never be negative or 0. That's why the graph looks like this, okay? Down here, it'll get, in this direction, it'll get infinitely close to zero, but it'll never reach the y-axis, all right? Let's try another one. Let's graph f of x equals log base 1/4 of x. All right. I already made a table here with some obvious easy numbers to use. So if you write log base 1/4 of 1/4 equals y, okay, that's putting this right here. What happens when you write it in the other form? You get 1/4 to the y power equals 1/4. Well, that should be obvious. It's 1/4 to the first power equals 1/4, so that would be 1. All right? Now let's put 1 right here. That would change this to 1. And if we write that in the other form, we get 1/4 to the y power equals 1. All right? That is also easy because the only way to get 1, by taking anything and raising it to a certain power, you'd have to raise it to the 0 power. Anything to the 0 power is 1, so this would be 0. All right? Now let's take 4 and put it here. So log base 1/4 of 4 equals y. Write it in the other form. You get 1/4 to the y power equals 4. Okay? Well, let's think about that one. What exponent would y need to be? We need to figure out what that would need to be. Well, if you guys recall, when you put -1 there, it's going to flip this whole thing upside down and make it to the positive 1 power. You flip it upside down, you have 4. So the answer is -1. So there's our values that we're going to graph. I think I accidentally erased a line here. That should be 1/4. Okay. So we're going to graph those points. We're going to graph the points 1/4, 1, 1, 0, and 4, -1. So 1/4, 1. 1, 0, and 4, -1. So this graph looks like this. Now, this graph will also x will never reach 0 because, again, it's impossible. As long as you have a positive base, no matter what exponent you use for y, what value, you can never get a negative x value. So this will never cross the y-axis. It'll just get infinitely closer. And there's our two graphs. Now, one other thing, if you do not have a graphing calculator to try some of these, I suggest you download this app. Let's see here. You should download this app right here. It's the blue one there at the top, EduCalc Classic. It's free, and it's so you can do a lot of graphing, even logarithms. You have to play around with it to find the logs, but you can graph logs using this app. I suggest you get it if you don't have a graphing calculator, because you don't really need a graphing calculator right now. That's it. I'll see you guys on Monday, and I will be sending out some homework. See you later. Bye.